Hey, hello everyone. Welcome to another session. The last session, we discussed all the problems, right? And because of that, I told you, whatever you are telling us, we'll take that into account. And that's why we are here with this all-in-one physics term 2 marathon session. It's a long session, I'm telling you this. Good evening, everyone. Welcome to the session, first of all. Gungun, Niriksha, Akansha, Disha, Fennel. And yeah, I read your comment about your paper. Easy peasy lemon squeezy paper. Yes. Hey, I'm good, Anshita. How are you? Puneet, hello. Sarthak, Mobuni, Sneha. Alright. So exam time is running for a lot of you, right? Nice. Alright, so hey, Sandhya, Muskan, Ankit. So, why do we need to do this kind of a session? 2-hour session. Yes, 2 hours looks very long, no? Before starting, I'm thinking it's a long session, right? I'm good, Janani. How are you? Right? The reason is, I'll tell you. Your comments have the reason with them. So, I'll just give you a brief idea of what we are about to do in this session. Yes. I'm good, Aryan. Hey, Kevyansh, Sarthak. Oh, Jinping. Nice. Oh, nice, Ayush. Very good. So you'll have a lot more sessions to see. Rest of you'll pass on to 11s. You'll meet new teachers. All right. It's 1st of November. Break, I won't say as such break you can take, but you know what? I won't make this 2-hour session too heavy for you. So that's why I'll tell you what I'm going to do. I have a few of the comments from your last session, which are discussing some of the problems you guys are facing. I'll talk about that. In between also, I'll keep on bringing the comments. Second, we'll do all the previous year NCERT and previous year questions. NCERT exemplar previous year questions, which we have already done, but we'll revise them. So, do you remember what I used to say you? The questions on which you got stuck for the first time, have a habit to see them again. So that's what we are about to do. Revise the whole concept, alright, but we'll also see a lot of shorts, and that is what I'm calling as breaks, alright. So those real life examples, real life experiments which are based on this particular chapters which we are learning for the term 2 exams, ये सब हम करेंगे आज, ठीक है? So session में, don't worry about the length. I would say enjoy the session, contribute your answers, your thoughts, your words, and revise कर लेते हैं पूरा subject, at least, I'll also be tension free. You guys are telling me you have revised a lot of times, but still you are forgetting, na? So ठीक है. Yeah, Disha, I remember you. Good evening, Jatin, Vineet. So let me tell you the comments which I have taken note of. So all of you gave me very good comments. Thank you for that. And some of you gave me doubts. So I'll tell you one very nice doubt which I saw was of Azmi. I don't know if Azmi is here in the session or not. But this was, I felt very attached to this kind of a comment. Nice. Very good, Lavya. Alright, Liresh. Yes. Alright. So this comment of Azmi, I'll take in the end. This is a very, what do I say? I feel it's a doubt of a child which I also used to have in my mind. So that's why. Alright. So this I'll take in the end. Then Paritosh had a comment. This I'll take sometime in between. Alright. Then Priya asked something. And Preetham. So Preetham, thank you. Yes. Alright. Oh, nice. Yes, Tanya. The reason this session is happening is because we tell you we have got you covered. Now this Priya's question, I have studied the whole syllabus several times. Now I get bored seeing it again. At the same time, I'm forgetting the concepts. This happens actually. You have learned everything so many times. When you are sitting alone in your room and you are trying to revise everything, you start getting bored and you feel I'm forgetting also. So that's why this session was important. That today, as a group session, as with your teacher and your friends, you revise the whole subject together. And that's why we have conducted this session. It's okay, it is long, but that's why. Alright? Yes. Let's start then. The concepts and questions we'll discuss, but we had 2 chapters, right? We had 2 chapters, electricity and magnetic effect of electric current. Yes, I know, Disha. That's why, don't worry, we'll discuss those questions also. Let's start with electricity. Alright, so what do I want? I want you to be ready with your pen, notebook and your concepts, whatever you have. And first of all, just believe you know everything. You know? Try to contribute, it's okay. Don't need to type a lot of things, but still try to contribute. You know? I just want that. Fine. Alright, thank you, Nancy. Okay. Tanya, your question is there in the session. Alright, come on. No, Ayush, it is 2-hour session. Let's start with the first thing we need to know in electricity, the Ohm's law. Come on guys, come on. Let's start. Hey Harimurli, welcome. Yeah, Maulya, it's coming. So Ohm's law. I'll tell you where you can get trapped. First of all, I'm telling you what is Ohm's law. Ohm's law is what? We all know, right? When you plot a graph between the voltage and the current across a resistor, right? Keeping what? Keeping the temperature constant. It comes out to be a straight line, right? More you increase the voltage, more current increases. And if you plot, this is actually a practical in your exams, right? So this is what we say Ohm's law. I'm just explaining you first of all what happens here, right? So this is something in Ohm's law. At constant temperature, the voltage across the resistor is proportional to the current. And that's why when you remove the proportionality sign, there is a constant which comes, which we are calling as the resistance, right? So R is the resistance and the unit is ohms. This is Ohm's law. Simple, right? Limitations is, I would say, it should be a conductor or resistor, but it should not be a semiconductor. But I would say don't think about that right now. I would say just think of temperature should be constant. That is the limitation for you, all right? Keeping the temperature constant. Don't change the temperature. That's important. The slope of VI graph is what we call as the resistance. Fine. Alright. So this is what Ohm's law says. Now let's talk about resistance. So when we are saying resistance, there is everything. Question, answers and concept. Both. That's why it's a long session. Alright. Nice, Fennel. Correct. So whenever I'm seeing the answers, I'm saying whenever you answer this now, please don't forget keeping the temperature constant, right? So that is important. Yes. All right. Fine. Come on. Let's move forward. Resistance. आवाज नहीं आ रही क्या? आवाज तो आ रहा होगा. So I'm perfectly audible, visible to everyone, no? Because I can see 1 or 2 comments of sound or something. Just give me a thumbs up. Come on, first. Am I clearly audible, guys? I'm right? Okay, fine. Nice, Haribulli. It's a correct answer. All right. So, resistance. What is resistance? In very simple terms, like how you and me discuss, don't always this thing now. I have seen a lot of students give the comments in last session that we are trying to cram the definitions, है ना? हमको रट रहे हैं हम लोग definition. Don't do the रटना thing. Don't cram the definition. Understand first of all what is this particular thing. Resistance. Resistance means obstruction. Okay. Resistance is what? It is an obstruction to the flow of current in a wire. Fine. Right? That resists the flow of current. You are right over there. Correct. So this is the thought regarding the resistance. All right. Then what is the formula? R is proportional to length. Now, when I say this, we started with experiments and we noticed that resistance is directly proportional to the length. Means you increase the length, resistance increases. You increase the area, the cross-section area, resistance decreases. It is inversely proportional. So that's why we came up to this particular thing, that resistance is directly proportional to length, but inversely proportional to the area. Fine. All right. Yes, everything is fine. Thank you, Shivanjani. Right. Then, and you know this, when you remove the proportionality sign, what do we get or what do we want? We want a constant. We put up a constant. Now, rho is what we call as resistivity. है ना? बिल्कुल. Red particles, they are vibrating. They are like the atoms, right? Rest are the free electrons which are moving. So that's why. Ab, what did you notice? Okay, length increase करने पे obstruction बढ़ गया तो resistance बढ़ गया. What happened when you increase the area? it's like, and whenever you want to think of this particular thing, na, why do we add a constant, Disha? So the reason is, whenever you want to remove the proportionality, when you put the actual values, there is some factor which is not giving you the exact resistance. So that factor is what? It is a constant. So this you will notice throughout. So today you are in class 10th, 11, 12 when you'll go na, all these derivations, they'll talk about the constant thing, be it gravitational constant, in electrostatics and everywhere. So okay, this is one thing. Remove the proportionality and put up a constant to get an equal to sign. Alright? Okay. So this is the resistivity. And regarding resistance, I would say yes, temperature increases resistance, correct? Temperature increases resistivity also. And for those who tend to forget this, I understand you might not. Just think of the free electrons are like the cars trying to pass through a tunnel. More obstruction, more resistance. If it's a bigger tunnel, they can pass easily. So this is all we have discussed already, right? So I won't spend a lot of time on this. Fine. For resistance, if you ask me, Priya, the factors would be, yes, length, area, and resistivity, right? The rho. But if you ask me for resistivity, right? Resistivity's unit is ohm meters. Easy to get, fine, right? It's very easy to get. Kaise niklega? Length is meters, area is meter square. So this is gone. So that's why, and the R is ohms. So what do you get? Ohm meter is resistivity. This is the unit of resistivity, fine. Okay? Alright? Yes. Shivranjani, it is related, right? Because of this formula. Rho is the constant which you put. How do you say it is related? It is related like this. And how you define resistivity? Resistance of a unit length of wire and a unit cross-section area. That is what is the definition of resistivity. If you want to define resistivity, how will you do it? It is the resistance of 1 meter long wire with a cross-section area of 1 meter square. This is 1. So that's why rho equals R. This is the definition. It's not difficult. Just think. कैसे करते हैं? कैसे define करते हैं resistivity को? All right? Yes, correct. Depends on nature of material. So that's very important. Thank you. That's very important. On which does the resistivity depends? Come on, think. When I say material of conductor, R and rho both depends on that. So there is one thing you can understand. Any other color of pen? All right, let me just change the color. Is this one better? All right. So whatever factor changes the resistivity, it will also change the resistance. Okay. This is one way of looking at it, I'm saying. So focus. Material of conductor, it changes the resistivity, means by default it will change the resistance. Fine. Next, temperature, it changes the resistivity, and that's why resistance is bound to change. Fine. Okay. Area of cross section, dimensions of the wire do not affect the resistivity, but they do affect the resistance. Fine. Length affects resistance, not resistivity. Simple, है ना? Mental ability पे सार्थक there's a session ना. Mental health पे sorry there was a session Khushbu ma'am took. Yes, correct Aditi. Nice. So regarding resistance and resistivity, are we clear? Fine. Any more questions on that? Come on, give me. All right, Sarthak will take this. Haan, Naveen, don't worry. This question is coming about heat. Nice giving, Guru. Resistance and resistivity में difference क्या है? Resistance क्या है? It's the obstruction to current. Resistivity के बारे में बोलोगे तो क्या बोलोगे? What will you say? It is the resistance of 1 meter long wire with a cross section area of 1 meter square. Simple. इतना ही definition you can just put. Resistance में give the formula. In resistivity, if you want to give the formula, it will be what? R multiplied by A upon L. That's it. ठीक है? Nice. Thank you, Rachita. All right. Series में don't worry. It's coming. The combination is coming. Okay. So till now, units are fine. It's okay, Gungun. Resistivity, Charvi, if you want to. So I think this is one question which a lot of you are asking. Definition, right? Definition of resistivity when you are asking. So resistivity का definition में क्या करोगे? R equals rho L upon A, means rho equals RA upon L. all right, R A upon L. Now, if both of them are 1, means rho equals R, right? So that's why resistivity is the resistance of 1 meter long wire with the area of 1 meter square. Simple, right? Yes, Anshita, definitely. Yes, Fennel, intrinsic property of a conductor. Correct. It's okay, Sarah, you haven't missed a lot. Electric shock, but don't worry, will come. All right, come on. An NCERT question. So, many of you might have tried this question before, but I'm saying focus on this and give me the answer again. All right. So this is a question. सबसे answer चाहिए भाई. ठीक है? Come on. Yes. All right. Electric shock पे अभी नहीं. Don't worry. A cylindrical conductor of length L and uniform area of cross section. It's an easy question. Come on, guys. Give me the answer. Right? Thank you, Madhvi. Has resistance R. ठीक है. What is it? And whenever you are doing a question, I would say focus on the language. ठीक? Focus on the language. A cylindrical conductor of length L, alright, what is given to you? Length L is given to me. Uniform area of cross section A, area of cross section is also given to me. Has resistance R. Another conductor of length 2L and resistance R of the same material has area of cross section. Has area of cross section, how much? That is the question. Come on. C. Okay. C. Option A. Alright, okay. Alright. Sneha, you are saying twice. Alright, it is C basically. You are saying 2A means the option C you are saying. Option C and A, I think they are fighting right now. Okay. Cool, ठीक है. अब ध्यान से देखना है ना, just focus. What the question is saying? I'm saying that whenever you face questions, please have a habit to make some reference images, some rough work in the rough work section. है ना? Rough work section is very important for every exam and especially subjective exams. ठीक है? Because objective में तो rough करते ही हैं हम. We anyways do rough work in the objective exams and just tick the right answer. But in subjective, we think, अरे, why to do rough work? We'll just do the answer straight away. No, rough is important. ठीक है? Madhu, which question? Because right now I'm saying C and A, all right? Resistivity depends on material, है ना? Material and temperature. Fine, Madhu answered your question. Yes. So first case is length is L, area is A, and the resistance is R. All right. Next time, what the question is saying? Length is 2L, resistance is still R. है ना? Resistance is still R, but you don't know how much area is there. This is A dash. Alright. So for the first case, you will say R equals. Now, just tell me, material is same, no? It's still the same material. Cylindrical conductor. In this whole question, does it says is material changed? No. That's why. Rho is same, right? Okay? Chemistry, it will happen. Don't worry. Leju. Yes. R equals rho L upon A. Fine. Let's talk about second one. R equals rho is same to L upon A dash. Now both the conductors have same resistance. Means you will just equate them. No. Rho L upon A equals rho 2L upon A dash. So rho and rho gone. L and L gone. So A dash equals twice, and that's why. What the answer is? Option C is the answer. Now, why did we go for option A? What was the mistake? Can someone tell me? Yes. Correct. Rho cancel. It आसान question था, है ना? इसमें कुछ था नहीं ज़्यादा. Yes, Tanya. It can be. All conditions, but you have to maintain the same. So if you are doing a room temperature, maintain in the room temperature, you will see close enough. So it's an experiment. It's a practical, you know what in class 10 we used to do. हाँ, equate ही करना था. Division mistake हो गया ना, right? Yes. All right. Yes. So Tanya, don't worry. It can be. It's doable. Correct. So Come on. You asked combination. This is the progress of electricity, right? You start with Ohm's law, resistance, resistivity. क्या होता है ना धीरे धीरे slowly what will happen? Your mind will start thinking of the flow of the chapter. Okay, whenever I'm thinking of electricity, I'll start with okay Ohm's law. I know Ohm's law. Resistance is fine. Resistor is fine. Definition is fine. Or unit is fine. All right. Next, I'll go for series parallel. This is the flow of the chapter. Just धीरे धीरे, है ना? धीरे धीरे. Develop this flow in your mind. Series combination. In series combination, the first thing which is very important is what is same? Current is same. है ना? That's true. Yes, Fennel. Yeah, you are right over there. Correct. In series, voltage gets distributed and current remains same. Yes, you are right, Fennel, over there. And equivalent resistance becomes what? R1 plus R2 plus R3. Thank you, Mathali. Alright, so this is the equivalent resistance. So that's why in series, it's pretty straightforward, right? The resistance is pretty straightforward. R1 plus R2 plus R3. That's same. Okay. Now, derivation, I won't do it. Alright, I won't do derivation right now because it's time taking little bit. वैसे तो आसान है यार, ठीक है. I'll just give you a hint. कैसे होता है, भाई? You said what divides? Voltage divides. So if it is V1, V2, V3, so V equals what? V1 plus V2 plus V3. मैं वैसे करने नहीं वाला था. I'm just telling you. So IR1 plus IR2 plus IR3 and just this is what IR equivalent. So simple, है ना? That's why. Potential difference across R2. Current. So potential difference हमेशा क्या होता है? V equals IR. So V2 equals I multiplied by R2. Simple, है ना? How voltage divide? Series में क्या हुआ? You started from here. This was a full nice capital V voltage. First resistance eaten up small part of that voltage. Second one the rest, and third one the bacha kucha. So that's why the whole voltage. And when you reach here, it is the 0 volt. So that's why we say this is the how voltage divides. ठीक है? Different color. Yeah. Today na there's some problem which I'm facing with this pen. So just bear with me. Yes, correct, easy, है ना? Why V divides? I would say in series V divides because the resistance takes up energy, and so I don't want to go into a lot voltage क्या होता है, क्यों होता है, कैसे divide होता है ना? That's why I'm saying कि voltage divide हो जाता है ना? इसमें क्या है कि voltage series में divide हो जाता है, current same रहता है, current remains same. In parallel, current gets divided into different branches, but the voltage remains same. ठीक है ना? Thank you, VNT. Guys, focus, yes. If you have equal resistances, how many? N. So for the total resistance, R plus R plus R plus R, how many times? N times. What is the total resistance? N times R. So this is the simple thing, right? है ना? Red, Lavya, I would say, let पता है चुभता है आंखों में. I'll try red. I don't think red will be helpful. Red better लग रहा है क्या? Battery, yes. Battery is not a charge provider. It's an energy provider. So it set up the electric field and then electrons can run. But it's okay. Don't worry. Don't talk about that right now. This is not the time. White. Okay. White, but पता है what the problem will be with white? All these questions or all these text is white. That's why. Dark yellow, that's why I'm saying dark yellow is better. Green? No. Okay, let's go with dark yellow. This is still better because you know what? This still works. Orange nahi yaar, orange. है ना? Red नहीं दिखता बिल्कुल. So, come on. Focus. Total resistance is N times the each resistance. तो इतना ठीक है. अब बात करते हैं parallel की. Parallel में क्या होता है? Voltage remains same, but what divides? The current divides. So this is the total current. This is the total current which is going in the wire. From that, one part I1 went into this branch, second part I2 went into this branch, and third part I3 went into this branch. ठीक है? Oh, nice, Srishti. Good technical answer. All right. Yes. Disney X, it's a good question. So that's why when you are talking about when you increase the resistance, heat is generated more, so temperature will change. So now it's not a validation. You are just going front and back in one time. So that's why keep the temperature constant. That is heating effect. है ना? उस time पे we don't talk about that wire from which you are talking about the heating effect. That's why. Yogi, put that in the comment section, है ना? और एग्जाम के बता देना कब है. Yes. All right. Yes. In parallel, so we have decided one thing. Current divides, voltage remains same. Okay. Now, whatever divides in every derivation, you starts with that particular thing. Means total current I equals I1 plus I2 plus I3. Now, I1, what is I1? If each branch has potential V, potential difference as V. So that's why V equals IR, means I equals V upon R. So V upon R1 plus V upon R2 plus V upon R3. Now, if this circuit did not look like this, if it looked like this simple circuit, this is V and this is R equivalent. So this is V upon R equivalent. So that's why all V get cancelled. है ना? ठीक है? Voltage, Madhu, you understand this, right? Voltage is what? It is the work done per unit charge when you bring it from infinity to a particular point. That is the voltage of that point. है ना? Yes? Thank you, Vansh. Hey, thug gamers. Alright, yes. So, this is the derivation. Fine. So, if derivation comes, you should be able to do it. है ना? In every derivation, you start with whatever is dividing. Make a note of that and then you start progress. है ना? Tanya, this question is coming in the session. Don't worry. Nice, Sanjana. Very good. Yes. So, this is the derivation. Fine. Now, what is our key takeaway? The formula which we derived just now. It is this. This is the parallel combination formula. है ना? So I'm saying कि हमेशा ना इसको रटना नहीं है. Always just don't cram formulas. Yes? Bold pen or another color which is bold. Okay. Don't worry. I'll just put pressure. Yes. So this is the formula, है ना? This is the formula, but it does not mean that you have to cram it. It means you have to understand it first. Now, if you have n resistors in parallel, means what happens? Which means what happens? Come on, think. 1 by 2 plus 1 by 2 plus 1 by 2, right? If you do this n times, and this is what? 1 by r. So, what happens? R becomes 2 upon n. So, that's why, finally, is R upon n. If you have n resistors in parallel of equal resistance R. Okay? Fine. Alright. Yeah, Toshi, the pen is causing problems today. That's true. Come on. Focus. It's okay, don't worry. I'll pressurize it and it should work better. Tanya, this thing is there. Right. So ammeters you connect in series and voltmeter in parallel. Simple, right? Drift velocity, Disha, you have went into 11. Don't worry, it'll come. Alright. NEAVD, the thing. So, parallel combination, the advantages. So, this is the question which I see was coming in the chat. Why do we have parallel connection at our homes? And you know what? This question is not necessarily will come in such a fashion only. It can only come as, there are various ways it can come. Difference between parallel and series connection. Advantages of parallel connection. Why do we have parallel connection in our home? Why not series connection? And we have other multiple ways of asking. But you know what? The answer still remains same, right? No, Shyamdhani. Then what do you have to use? 1 upon R1 plus 1 upon R2 plus 1 upon R3. Yeah? Yes. Correct, Harimurli, you are right. Yes, voltage is same, current is different. Alright. So what you have told me, first point you have given me is in parallel voltage remains same. Alright. In parallel there is an individual control on each equipment. It doesn't work like that. If one equipment becomes faulty, the whole circuit stops working. That doesn't happen, huh? So voltage constant, correct. And then before starting derivation, what to write first, Madhu? You have to write what is happening in series. Voltage is dividing and current remains same, and that's why. Then you proceed in parallel. You start with current dividing and voltage remains same. Okay? So nice, Lavya, very good. Yes, that is pretty much. So 2 points are enough, I would say. Hai? Voltage remains same, and second, you have control over each equipment separately. Okay? All right. Yes. So that is the whole thing about why parallel connection, and that is why we have parallel connection at our homes also. Correct? Because you might have noticed each equipment, whatever you buy, it has a power rating. It always say 220 volts. Then the power, kilowatt hours, right? So this thing is given to you in every equipment. Kilowatt, not kilowatt hour, sorry, it's energy. Kilowatts or watts, right? So that's thing. R upon N, yes, Naveen, you can use. Only condition is if all resistances are equal. But make sure you notice this carefully, because many of the times the resistance might not be equal. Hai na? Correct. Yes, very good, Fatima. Yes, all right. Yes, Suhani, that's also good, true. Okay, come on, come on. Next question. A hot plate of an electric oven. All right, we have half an hour is done. Don't worry. Minimum and maximum. Smita, don't worry. I'll take this. Yes. Electric fuse, Shivanjani, coming, don't worry. It's revision. A hot plate of an electric oven connected to a 220 volt line has two resistance coils, A and B. Alright. It's again an NCERT question. Each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in the three cases? So this is kind of a question which you were asking. Yes? Right? So 1 by 3, Thug Gamers, almost. Close to 1 by 3. Yes? Don't worry, Sanjana. We'll do this. We'll do that. Labh, Hindi English mix रहता है यार देखो. The reason I speak more English is because I have told this multiple times कि English पे पकड़ होना थोड़ा जरूरी है. Hindi is important, ठीक है, हिंदी है, but exam हिंदी में है, लिखना हिंदी में है. You have to write your answers in English, right? So think, and a lot of time what happens, you think in Hindi, but you want to write in English. So it's better if more and more you talk in English. At least यहाँ पे, घर पे थोड़ी करते हैं हम, घर पे तो हिंदी में बात करते हैं. That's why I'm saying, at least in sessions, let's practice English also. ठीक है? ठीक है? Yes, I'm getting answers. Nice. Wow, good. Tanya, Fennel, very good. So yeah, what is the question? Question is saying a hot plate of an electric oven connected to a 220 volt line has two resistances, coils A and B. Fine, each 24 ohm. Okay. Voltage is given, two coils are given 24 ohm. They can be used separately first, in series or in parallel. Okay, I have a control over this. Either they can be used separately, in series or in parallel. What are the currents in the three cases? Mind it, there is a thing. You have a control, you want to use in series or parallel, but there is one more thing which which may be used separately in series or in parallel, and in the three cases. What three cases? ठीक है, one is series, one is parallel. What is the third one? What is the third one? One is series, one is parallel. What is the third one? Come on, someone. Thug Gamers, it will come. I mean, without you asking for it, it will come. Separately is fine. Alone, right? Single resistance, only one coil is used. That is possible. No, you have a control over that. And that's why one case is this, second case is in series, and third case is in parallel. Simple. So if you want to find the current here, it's what? V upon R. Here it is 220 upon total R is what? 48. Here total resistance is how much? Now, a lot of you asked me, can we use R upon N? Right? Here, 24 and 24. Equivalent resistance is what? 24 by 2, 12. And even if you forgot this formula, you could have used 24. You could have used 1 upon 24 plus 1 upon 24 equals 1 upon R. So this is what? 2 by 24 equals 1 by R. So that's why R equals 24 by 2, that is 12 ohms. So that's why that R by N is not a formula. It's an observation, a derivation from this original formula. So don't worry. Okay. The third one is 220 upon 12 ohms. This is I3. And then it is simple calculation, right? So Ohm's law, V equals IR. How will you write the answer? Yes, using them as standalone resistances. Fine, good, nice. Very good. So that's why. First case, and while answering this kind of a question, I'm assuming you have to draw the diagram. It's important, don't forget that. पहले diagram बनाना है, then applying the formula, finding the current. फिर series वाला बनाया, then you make the series diagram, then you apply the formula and find the current. And similarly, the third one. So it's easy. I'm just telling you, you did not understand the question. So question में क्या था? Voltage was given to you, 220 volt. The question is just trying to play with you with the language. 220 volt is given to you. He said there are two coils, A and B, with each having resistance of 24 ohms. ठीक है? Basically, it has given you resistance of both the coils. Which बोल रहा है? Which may be used separately. या तो इनको separately use कर सकते हैं, series में कर सकते हैं, parallel में कर सकते हैं, and then it is saying three cases. Three cases means one is series, one is parallel, and one is alone, standalone. Simple, है ना? ठीक है? All right. So यहाँ तक हो गया? Easy. It was simple calculation afterwards. Yes, Disha, you are correct. Nice. Fine. The next topic is something which I have seen a lot of you get confused upon, alright? So let's focus on this, alright? And someone asked me to use this phrase. Come on guys, focus, right? Heating, come on. Joule's law of heating. अब Joule's law of heating क्या होता है? ठीक है? Master of learning, it's coming. If you are in 8th, you will also get a new class. And if you are in 9th, don't worry, you will also get. So there is a huge thing coming your way, don't worry. You will get the notification very soon. Chalo, Joule's law of heating. So whenever, yes, heat dissipation is pretty confusing, I understand. So pehle na, before moving on, I would say first of all, socho. Heat kya hai? It's an energy, alright. When current is passing through the resistance, there is a dissipation of energy which is happening in which form? In the form of heat. है ना? ठीक है? All right, fine. So heat dissipated by a resistor, and that's why we always say there is a heat dissipation. मतलब क्या होता है? Surrounding में lose कर रहा है, dissipate कर रहा है. Alright, so Joule's law of heating, and उसमें एक law है जिसको हमने बोला Joule's law of heating. Alright, so very soon, don't worry. April first week around, you will get the notification. Don't worry about that. Yes, I'm coming to that, directly or inversely proportional. So the Joule's law of heating says that heat is directly proportional to square of current. Now again I'm telling you, when this law came, क्या हुआ पहले? You observed things. Let's say you are studying the heat dissipation on one resistor. You observed कि भाई जब हम करंट को डबल करते हैं तो heat dissipation 4 गुना हो जाता है. हम जब रेजिस्टेंस को डबल करते हैं तो heat dissipation 2 गुना हो जाता है, right? When you double the current, heat dissipation is 4 times. Double the resistance, heat dissipation is double the time, double. So this gave you an idea that H is, right? H is proportional to I square R into T. Correct? Fine. Nice, well. Alright. So this is what? H equals I square R T. अब heat है, right? It's heat. Heat is energy. Unit of energy is? Yes, Fenel. Correct. हाँ, Fatima. Yeah, I'll derive that also. I'll tell you how that also came. It is joules, है ना? So specifically, H equals I square RT is what we are calling as Joule's law of heating, है ना. सो कभी भी कोई पूछेगा, whenever someone asks you Joule's law of heating क्या होता है, I square RT, है ना. That is simple. Now what you can do, you can combine this along with the Ohm's law. What is Ohm's law? V equals I into R. You can combine this one and this one and you will get three formulas. And I understand that is where you are getting confused, है ना. कहाँ confused हो रहे हैं हम? ये तो हमको पता था. We knew this one. It's fine. Now when I'm saying this is I square R means I equals V upon R. I square is V square upon R square, right? So H became what? It became V square upon R square into R into T. So that's why it became V square upon R into T. Now इसको हम Joule's law of heating नहीं बोलते. इसको हम Joule's law of heating नहीं बोलते हैं ना. This is a rearrangement of the formula. But Joule's law of heating बोलते हैं I square RT को. Fine. अब question will come, when to use which formula? Don't worry, we'll do that. Yes, Sonali. I square I would say you should use. So, है ना? I square. Correct. So this is one of the way you got this. Fine. So, and another is H equals I square RT. Means can I write I multiplied by I multiplied by R multiplied by T, right? And this is IR is what? V. So this became VIT. So this is how you just made some rearrangements and got these three formulas, है ना? Heating element, the coil goes, na? The current flows through coil, that's why. Ha. So Haritha, I'm telling you this. You are getting confused with the usage, how we are using different formulas. So Joule's law of heating, whenever someone asks you, just say directly proportional to current, square of current, resistance and T. If someone says, sir, how much it is proportional to voltage? I would say stop right there. This question will not come first of all. The reason, I'll tell you. So let me just tell you first of all devices. Bulb, fuse, everything which uses heat, that uses this formula. Right? That's fine. Yeah. So that's true, because the questions which we are targeting here, they are either previous years or NCERT exemplar good question. That's why, at least for exam point of view, these questions are very important. How do you get third formula? Third formula, when you ask me, third formula is what? VIT. So I square R into T. I'm saying I square क्या होता है? I into I multiplied by R multiplied by C. And this IR is what? V equals IR. So that's why IVT or VIT. Simple, है ना? All right. So don't worry. We'll practice when to use which formula from this question. Come on. Yes, Harimurli, that's true. Alright, Dharunesh, I have answered your question. Huh? Come on, this question. This is CBSE 2018 3 marks question. Last year, previous year question, 18, 19, 20, around 3.5 years before, right? है ना, easy है, that's true. ठीक है, चलो question, come on. For the combination of resistors shown in the following figure, find the equivalent resistance between M and N. Come on. Yes. Shyamdani. Okay. Rest of the guys, you focus on this question. Try to solve this question. Give me the answer. And meanwhile, I'm just explaining Shyamdani. Okay. कुछ नहीं था. Joule's law of heating पता था ना? What was Joule's law of heating? I square RT. Then use V equals IR and just rearrange that formula into two more forms. Simple, इतना करना है ना. So that's why I square RT. इसको when you put the value of I as V upon R and you put here, you will get V square upon RT. When you put I square को ऐसे लिखोगे, I multiplied by I. So then you will get V I into T. बस इतना ही है, ठीक है. Nitesh, I'm telling you कि I square RT पे focus करो, V square upon RT ना. Don't focus on that right now because that is a rearrangement. directly proportional to current ही आता है, but that is a rearrangement, and how it is rearrangement I'll tell you. You will understand with the question. Yes, correct. Nice, very good, Sadiq. Yes, yes, nice, nice. I got the answer. Very good, Sanjana. So, for the combination of resistors shown in the following figure, find the equivalent resistance between M and N. So, these are the 2 points. Alright, these are the 2 points. इनके बीच में क्या निकालना है? You have to find the equivalent resistance. Simple. So, R1 and R3 are in, R1 and R2 are in series. That's true. R3 and R4 are in parallel. Very evident. So, if you want to find first of all the equivalent resistance of this two, the RP. RP will be how much? So, if you have only 2 resistances, and you are right, I can see a lot of correct answers over there. This is what? R3 multiplied by R4 upon R3 plus R4. I'm writing this directly, but you know what? You can also go through with 1 upon R3 plus 1 upon R4 equals 1 upon RP. That is also fine. Don't worry about that. Then R equivalent is RS. That is what? R1 plus R2 plus RP. So, yani ki this whole thing plus R2 plus R1. Simple. This question is, quite easy. Not a problem over there. Fine. Then the question is asking, state Joule's law of heating. So, the thing which you are asking first of all, कि अगर दे दिया कि क्या directly proportional होगा voltage से, this kind of question, you know what? This question is going to ask about the law. That's why Joule's law of heating, the word is important in itself. That's true. So that's why this question is coming I square RT. Now you have to say Joule's law of heating states when a current I passes through a conductor of resistance R for time t, heat developed is equal to product of square of current, resistance and time. Simple. This is what we have just discussed. Joule's law of heating. Fine. Nice, nice, Hari Murli. Very good. 3 lines. Which 3 lines? Oh, equivalent to. Yes. See, how much heat dissipated or how much energy is utilized in how much time. The rate of utilization of energy is electric power. Fine. Why we need a 5 ampere fuse for electrical iron which consumes 1 kilowatt power at 220 volt. So this was the third question. Now in this chat itself, someone asked me, sir, minimum maximum current ka question karwana hai, right? I think I might have missed the name. Yes, nice, Seema, very good. हाँ, 3 नंबर में ज़्यादा काम करवा रहे हैं, ये बात सच है. Alright, कैसे करना है? Why we need a 5 ampere fuse electrical iron which consumes 1 kilowatt power at 220 volt? So, the reason, you know what, why you did those modifications to that formula, every time it's okay, you can use I square RT और वही formula is it matters, लेकिन V square upon RT is my recalibration or reformation of that formula. How it helps me? Question जल्दी solve करने में आसान होता है बस. That is one thing. क्यों? यहाँ पर if you wanted to use I square R, right? If you wanted to use, let's say I square R is the power. I square RT heat होता है तो rate of heat dissipation is I'm saying power. So that's why I'm saying कि I square R is the power. Fine, correct, right, fine. अब I square R अगर है, how do you find this? How do you find this? Okay, 1 kilowatt is the power, voltage is given to me. So power is given, voltage is given, all right. But I know only this formula, right? I don't know I also. You'll have to make the rearrangement, no? So which one you can use? V square upon R equals P. This will give you the current. But what do you want? You don't want resistance, you want the current, right? You want the current. So that's why you are using P equals V into I. अब ये देखो, तीनों formula same ही तो थे. You just notice which formula is helping you out faster, है ना? Correct? Alright? Yes, very good. So P equals V into I. So when you solved it, you got what? 220 upon, oh sorry, you got 1 kilowatt, means 1000 watt upon 220. This is what? This is the current, right? So P equals V into I. When you solved it, you got current as 4.54 amperes. अब ये चीज बताना, if let's say this was an objective question, I mean although you are getting most of the subjective questions, but still थोड़ा ऊपर रखते हैं ना. Yes, nice. I can see a lot of correct answers. Yes, Anup, you are right. Yes. Very good. I mean, yes, all of your answers are correct. Slightly higher, not too high. If you keep it too high, then क्या होगा? I mean, even though there is short circuit, your fuse will not melt. But what is it? It's a safety device, no? It should melt after the current increases to a significant limit over than what is prescribed for it. That's why, है ना? इसलिए you have to keep slightly higher. भाई normal functions में जब सब कुछ ठीक है, 220 वोल्ट मिल रहा है, उस टाइम पे कितना पावर यूज करेगा? 1 किलोवाट. कितना करंट चाहिए होगा उसको? 4.54, राइट? इन नॉर्मल कंडीशंस इट विल रिक्वायर करंट एज 4.54 एम्पियर्स. बट व्हाट इज हैपनिंग टिल हियर? तो एनीवेज इट विल गेट, थोड़ा बहुत तो चलता है. A slight up and down is fine. So that's why I'm saying 5 amperes, let's keep it. I'm not saying keep it 9 amperes. It's double, not required. है ना? Short circuit में क्या होता है? कि let's say, what do I say? To the body, current came and the body is touched to ground. So क्या होगा? Current सीधे बहुत ज़्यादा current draw हो जाएगा and lot of current is drawn and the whole current will go to this thing. So that's why short circuiting is something malfunctioning in the circuit. Suddenly resistance zero हो गया. कैसे? Wires fuse हो गए. This live and neutral they merged. यहाँ क्या है? Insulation melt हो गया and it touched. So sudden current. So that's why. हाँ. उतना से. Yes. So fuse should be selected such that its rating is slightly greater than the maximum current drawn by the device, and that's why this is important. ठीक है? Yes. Very good, Sonali. Nice, nice. Very good. Okay. Now this is again, this question we have done. Oh, nice, Nabi. Thank you. So fuse wires, no, I would say it depends what rating of fuse you want to make, and that's how you choose the wires, all right? I mean, in plants, if I tell you, a lot of times we use platinum. So yeah. Yes, Akash, you are right. All right. So this question is quite important, and important. I would say it's quite analysis based. Image is not complete. No, the images has given you na 220 volt plus minus. So अगर ऐसा भी, whenever you get such a thing also, don't be confused, है ना? It is showing you that over there was some power supply providing 220 volts. That's it. So why is it impractical to connect an electric bulb and electric heater in series? Paritosh, we have to repair it. So this is one thing with fuse, and that's why we go for MCBs now, miniature circuit breakers. Fuse, it gets melt. You have to buy a new one. MCB क्या down हो जाता है, फिर ऊपर कर देते हैं. Nice, thank you, Sneh. Yes. Oh, nice. Very good. Sonali, in very high-end fuses, I remember we use platinum also. Yes, very good, very good. Yes. So I'm saying, so I will give you, there are easy ways to answer this question, but there is a way which is something, you know what, as a students or as people who are learning concepts, we should know that it's okay. It's fine if you don't use that. I mean, in simple words, why is it impractical to connect electric bulb, electric heater in series? आसान भाषा में तो you can also say it's in series. If one stops working, other one stops working, that's why it's fine, है ना? But why? Why only electric bulb and electric heater? Electric heater में you will always notice the power rating is higher, right? 1 kilowatt and 220 volt, 10 watt and 220 volt. If you are given power and voltage, you can find resistance. V square upon R equals power. So I'm doing this analysis for you, है ना? Correct? Nanajna, it's a previous year exam. It's a previous year exam question. Resistance is 48.4 ohms. So you don't have to do all of this. This is for you and mine understanding. You will write the answer only, but understand why. ऐसा हुआ क्यों? R is 48.4 ohms. For this resistance will come to be how much? How much? V square upon R, you will get 4840 ohms. पहली चीज, the first thing, the first myth that breaks in a lot of students' head is, sir, resistance का heater का resistance तो जो है कम आया है than bulb. I mean, in our mind, we always used to believe, अरे heater है, resistance high होगा इसका. It's not necessary, है ना? It's not necessary. Resistance is 48.4 ohms, and for the bulb, resistance is 4840 ohms. Yes, it's a previous year exam question. So this is the first myth that breaks. Oh, resistance does not mean the heater will have high resistance. है ना? जरूरी है ये. Yes. नहीं सोनाली, that's not true. If very high melting point, तो वो melt ही नहीं होगा कभी. Thank you, खुशी. Right, nice. Yes. So पहली चीज, हीटर का रेजिस्टेंस कम है, बल्ब का रेजिस्टेंस ज्यादा है. ऑलराइट, व्हाट इज द टोटल रेजिस्टेंस? नाउ दीज आर टू रेजिस्टेंसेस इन सीरीज, दोनों को सम कर देंगे हम, वी फाइंड द इक्विवेलेंट रेजिस्टेंस. ऑलराइट, सो अब इक्विवेलेंट रेजिस्टेंस निकाला हमने. और हाँ, विद पावर एंड वोल्टेज यू कैन आल्सो फाइंड द रिक्वायर्ड करंट. हीटर रिक्वायर्स 4.5 एम्पियर्स, बल्ब रिक्वायर्स 0.045 एम्पियर्स. डिड यू नोटिस नाउ? हीटर का रेजिस्टेंस कम था, इसको करंट ज्यादा चाहिए था. Right? So if you want more heat dissipation, what would you increase? Resistance or current? You will increase the current. क्यों? Current का तो square होता है ना? It is I square. That's why. समझे? Right? This is 0.045 amperes. Total current will be how much? Total current or resistance? Total resistance will be how much? भाई इसको और इसको add कर दो, you will get this much. What is the current it is getting as a circuit? सीरीज में करंट तो सेम रहता है. So how much you are getting? 0.045 amperes. Your bulb is working fine. What about heater? Heater requires 4.5 amperes, but how much it is getting? 0.045 amperes. कुछ काम का है इसके? Is it okay for heater? No, it will not work. कुछ नहीं दे रहे हो तुम तो उसको, right? That's why. Yes. So that's why. This is the mentality. That's why I'm explaining this to you. क्योंकि इस क्वेश्चन के अंदर वी लर्न टू थिंग्स. जरूरी नहीं है हीटर का रेजिस्टेंस ज्यादा ही हो. इट्स नॉट नेसेसरी दैट हीटर रेजिस्टेंस विल बी हाई ओनली. नो, इट इज लो. करंट रिक्वायरमेंट इज मोर. फाइन. आर लाव्या यू कैन फाइंड यूजिंग व्हाट? पावर इज गिवन टू यू एंड व्हाट इज गिवन टू यू along with power? The power and voltage is given to you. So V square upon R equals power, you can find R also. Power equals V into I, you can find current also, है ना? So these things you can find. Yes? Nice. Thank you. All right. अनूप, सीरीज में नहीं होता है कभी. They are all in parallel. राइट? सो उसको वोल्टेज पूरा मिलता है, वो करंट ज्यादा ले लेता है. इन पैरेलल तो करंट कैन बी डिफरेंट ना, एंड दैट्स व्हाई वी यूज पैरेलल. फाइन. यस. सो हाउ डू यू राइट द आंसर? तो इट्स ओके सोनाली, इफ यू couldn't understand that, understand the answer first. It is impractical to connect electric bulb and electric heater in series because पहला, the heater and bulb have different value of resistance, right? Which means the potential will drop according to resistances. V equals IR in series. So you can answer this question keeping in mind it's a series connection. Series में क्या होता है? Potential divide होता है, दोनों का resistance अलग है. Both have different resistance, means both will require different voltage, or both will get different voltage. Fine. Then they need currents of widely different values for proper operations. That's why both of them are in series. So what do you get? They are getting same current, but do they require same current? No, their requirement is different. That's why. They need currents of widely different values for proper operation. Now, this third one is quite common, right? In every series connection, this statement will come. If one appliance fuses, the other will also fail to operate. और चौथा वाला क्या है? The fourth one is, since effective resistance increases, the value of current and hence the power consumed by each appliance decreases. Right? Getting? All right? Yes. All right, yes. Okay. So this is the whole answer for this. And I mean, first two answers, the reason I explained this to you, because the first two answers you might be able to comprehend. समझ में आना चाहिए. That's why. And the last two were all fine. All right. Last point. Okay. Effective resistance increases because what happens in series, the effective resistance increases, no? Alright, the value of current and hence power consumed. If effective resistance is increasing, what is current? Voltage upon total resistance. The current is decreasing, means I square RT, it will decrease for both, no? So that's why. Surya, got it? Okay. So, Surya, I would say this question, try to do it yourself. Just keep 220 volt, 1 kilowatt and 220 volt, 10 watt. Whenever you analyze this question, you will get the answer. It's a quite simple. Just you need to take some time and do it yourself. It's an easy question. Don't worry. है ना? Nice. Yeah, Finel, I'll try. Don't worry. Third point is easy, no? In every series connection it happens. If this one fuses or if this one gets malfunctioned, this one also not work. It's a series connection. If there is a break, the whole circuit breaks. Okay? All right? Yes. Sneh, Finel, PDF. Don't worry. I'll try from my end. Cost questions are not difficult. Just find kilowatt hour. No? Come on, electric power. So power consumed is V into I. Alright, we have learned about this right now. Power is VI, I square R and V square upon R. We just learned this. Don't worry. Resistivity or resistance? Arey Meenakshi, that's easy, no? Don't worry, I'll tell you in between. Okay. Hey Surya. Yes. So power consumed, so that's why heat is VIT. So every time it is what? The rate of dissipation of heat or the rate of consumption of energy. In any way you can just rephrase it. So VIT per unit time upon T means VI. So har cheez mein in every formula just remove T, it becomes power. Simple, hai na? Yes. Oh, Surya. I think two people have asked this question. Resistivity and resistance. It's easy question. No, R equals rho L upon resistance is the obstruction to current. Resistivity is what? It is resistance of a unit length of wire which has unit cross section area. Okay? Resistivity is a constant. It depends on material, temperature. Resistance depends on length, area, material, temperature. So all these things, right? So yes, question, and this one is a poll question. All right, come on. Power and heat. Rate of heat dissipation is power, Naveen. Effective resistance, total resistance. Don't worry, Surya. Tomorrow's subject will tell you in the end. Yes, Sonali, you are right. Yes. Okay. So ready with your answer? I'll give you 30 seconds and your time starts now. Raw in resistivity. Raw. Resistivity as such symbol wise though we don't unit if you're asking me ohm meter and the symbol becomes ohm meter. This is for resistivity, right? Yeah, I mean actually free electrons, that's why. Okay, option C you are saying, है ना? All right. B and C. आकर्ष, इसको लंबा डिस्कशन लगेगा थोड़ा सा, so I won't take it right now. All right, so yes, the answer is C. You guys are right over there, correct. तो अब क्या है कि what the question was asking, electrical circuit, there are 3 incandescent bulb A, B, C of rating 40 watt, 60 watt and 100 watt. ठीक है, each bulb had a rating of 40, 60, 100. A rough diagram I have drawn in my rough work. Fine. Connected in parallel to an electric source, and now source is what? Let's say it's V. I'm assuming it's V, you know? And it's a parallel connection, means all 3 are getting V only. Fine. Which of the following is likely to happen regarding their brightness? अब brightness के अंदर क्या होता है? Yes, Sushmita, that is correct. Yes, brightness. Whenever some question asks you, yeah, Surya, I'm explaining in English, no? Whenever some questions ask you about brightness, what you have to focus on? किस पे focus करेंगे हम? We have to focus on power. Power dissipation. If higher is the power dissipation, means higher is the brightness. Fine. This is important. All right. Okay. It's okay, Gungun. Yes. So now in parallel, every bulb is getting same voltage. है ना? Same voltage it is getting. All right. Which means power dissipated is V into I. All right. The bulbs, they are connected in parallel, means each is getting equal voltage. That is also fine. Let's analyze. है ना? This is for class 10th, no? Yes, correct, yes. So for, let's say A, let's talk about A, first bulb. A is 40 watt upon V. Current for B is 60 watt upon V. Current for C is 100 watt upon V. All right. This is what? The current, है ना? All right. Current I have got. IA is less than IB is less than IC. Which one is getting more current? C is getting more current, है ना? C is getting more current. And that's why more power is more brightness. All right? Yes, you're right. So, fine. All right. So in parallel, I'll give you a simple thought process. Dirishna, I have answered your question. It's ohm meters. Raw, I'm not understanding what is raw you are asking. So yes, in parallel, you have noticed in your home, what is the connection? It is parallel. And you have also noticed a 10 watt bulb glows brighter than a 5 watt bulb. A 20 watt bulb glows brighter than a 10 watt bulb. A 50 watt bulb glows brighter than a 20 watt bulb. So in your home, things are in parallel. So in parallel, what happens? जिसका power ज़्यादा, उसका brightness ज़्यादा. Simple. ठीक है? Right? All right. Yes. Incandescent here, it's what? The filament bulb. Electrical energy. So this is like the last topic from electricity. Don't worry, we are starting the magnetic effect of electric current. 1 kilowatt equals 1 unit, and 1 kilowatt hour. Kilowatt is 1000 watt. 1000 watt. R is 3600 second. So that's why. This question can come in 1 mark, a fill in the blank kind of thing. है ना? हाँ, series में होता तो लव, that's a good question. सीरीज में होता तो क्वेश्चन थोड़ा सा चेंज होता है ना, क्वेश्चन थोड़ा सा चेंज होता. व्हाई? इन सीरीज यू वुड हैव फाउंड क्या, आई, एक कांस्टेंट आई कितना मिल रहा है, एवरी बल्ब इज हाउ मच गेटिंग द करंट, दैट टोटल करंट यू विल फाइंड आफ्टर गेटिंग द टोटल रेजिस्टेंस. दैट इज अ चेंज ऑफ थॉट प्रोसेस. Anup, yes, you can. हाँ, रो, yes, resistivity, रो है resistivity. ठीक है? Alright, let's come to this question. The last question, I think, and it's, you know what, CBSE 2020, I mean, very recent, 5-mark question. अनूप कर सकते हैं. You can. But you know what, I would say, be very clear when you are doing with resistance. बस ये मत करना कि power is V square upon R, so किसका resistance ज़्यादा, उससे कर दिया, है ना? So that's why. Give it some relation. What was given to you? Given to you was power rating, right? है ना? So that's why. बस. We are starting with magnetic effect to electric current in 5 minutes. No, Anisha. It's not like that. Usually what it comes is lower power gives you more brightness. Right? Anil, it's okay. Spamming. Right, yes. So, electric bulb rated itna and itna. 200 volts, 100 watt. What is its resistance? Energy. It's a very simple question, guys. Okay? I am going to run this through fast. Power consumed V square upon R, 200 volt, 100 watts. So V square upon P, and you will get the resistance. 400 ohm. Yes, I'm 484. I think there's something, no? 200, not 220. 200 volts, 100 watts. So V square upon P, you will get the R. Second, calculate energy consumed by 3 such bulbs if they glow continuously for 10 hours for complete month of November. And yes, you are right. This thing, what happens? What happens here? You have to, first of all, know in November how many days are there, right? Because 3 such bulbs, power consumed by each bulb is 100 watt, means it is 0.1 kilowatt, alright? Energy consumed by 3 bulbs in one day, by 3 into power of each bulb multiplied by time. How much time? 10 hours each day. So that's why 3 multiplied by 0.1 and itna. So on an average, I mean every day, these 3 bulbs are taking power of 3 kilowatt hour. In the month of November, kitna power lenge? How much power will they? How are they connected? It's at your home, it's given, no? So they are in parallel only, right? But in this question, what is important? How much energy they are drawing? Means every energy, every bulb, whatever energy it's drawing, this is how you pay your bill of electricity, no? How many units you have consumed. So regarding that, it's going on. Yes, it's okay. Come on. So energy consumed in 30 days. Why 30 days? So this is something which we should be careful about. So in this question, I can see only one place where you can make a mistake. November. November में कितना दिन होता है? Right? Yes, 5 नंबर मिल रहे हैं इसमें. कितना होता है? January, February, March, April, May, June, July, August, September, October, November. I mean, I'm comfortable with this. So every dip is 30, every bulge is 31. So you can do that. Alright? So yes, November is 30 days. So that's why 3 kilowatt hour into 30 is 90 units. And 1 kilowatt hour is 1 unit. Simple. Hai na? It's okay. Nice. 30 days are there. Very good, Asna. Calculate the total cost if the rate is 6.5. I mean, number of units multiplied by cost of each unit, and that is the answer, right? Yes, Fenil, you are right. Okay. So, electricity is done. Yeah, new type question, you're right. But you know what, I don't want to change this question is because these questions are important NCERT and previous year questions. And these questions, I would say, it's very important for exams. I mean, I don't see a lot of, I can give you more difficult questions, but I'm not giving it right now. I don't want to demoralize you, alright? Yes. 30 दिन वाले आते हैं, but ठीक है, कभी दे दिया, December दे दिया, then, right? So, now that we have already studied for around 15 minutes, there is this question which we had in last session. So that's why I'm saying Calbrio, yeah, don't worry, we'll do that. So how to concentrate for more time, as you know, you focus on one thing for 1 hour 115 minutes, then you can't focus more than that. Right now, how much time has it happened? कितना time हो गया? It's been 1 hour 15 minutes. So the reason I took this question here is because very difficult questions. Okay. The reason I'm taking this question is because this is what we are doing. And you know what? I completely understand. When you are studying alone in your room, it happens. I mean, you tend to get bored, and slowly what happens is you lose concentration. So what I'm saying, what you can do is same intensity, either take breaks. There are two ways you can do it. First of all, 1 घंटे बाद you take a 10-minute break. So always give yourself reward. Once you have achieved something, I targeted, I'll cover this in 1 hour, and then you have taken a break and then you go. है ना? Yeah, Sonali, don't worry. So then what happened? Then what happens? Give yourself reward, enjoy the break time, and then go back to study again. That is one way. Second is thoda sa aur. So when you might have seen, when you start running, what happens? 5 minutes बाद you feel हो गया. But if you just keep on running for a little more, you feel थोड़ा 10 minutes और चल जाएगा. You know, I can run for more 10 minutes. So that's why I'm saying push yourself slowly. So don't worry, है ना? It's all in your mind. बस हो गया, I'm done. So take care, है ना? Don't worry about that. Eat a chocolate, yes. Sai Baba. All right, yes, come on. So next chapter is magnetic effect of electric current. And let's start with the simple thing, the simplest thing we have in this chapter, the magnetic field lines, right? So this is very important. Yes, Pomodoro technique is very good. That is nice, Fennel. And people who don't know, just have a look, just Google this thing once, Pomodoro technique. It's important, efficient, and it helps. Distractions se bachati hai, at least, I would say. Directs from north to south pole outside the magnet and from south to north pole inside the magnet. So this is regarding magnets we are talking about. Outside the magnet, north to south, inside south to north, which means they are closed lines, right? Okay? Magnetic field lines form continuous closed curves. The degree of closeness of field lines determines strength of magnetic field. How close the lines are, it determines the strength. Fine. Yes? Okay, Harimurli. No two field lines intersect each other, and that is important, right? No two field lines intersect each other, because if they're intersecting means at that point there are like two directions, right? So that is not possible. That's why. Yes? Cool. So magnetic field line, this was simple. Let's move forward. The straight current carrying conductor, because this is something which, you know, which gives the understanding of this chapter. So straight current carrying conductor. What is there? Hindi, English, mix. Don't worry, hai na? Yes. Yes, Fennel, you're right. Correct. Oh, nice, Deepak. Anime. All right. Magnitude of magnetic field, I would say in this class, hold your urge for a while. It's coming for you, 11th, 12th. Don't worry. Current carrying conductor can produce magnetic field. So Hans Christian Ørsted experiment, right? There is a magnetic field associated with the flow of current as well. So what is that? If you have a straight current carrying conductor, we know there is going to be a magnetic field associated with it. Iske saath ek associated magnetic field hoga. Fine. Now, if current is going upwards, the field looks like this. I'm not using clockwise or anti-clockwise, alright? If current goes down, the magnetic field lines look like this. Again, I'm not using, right? English to desi hai ekdam. Yeah, my English is just, it's okay. It's desi. So when it goes down, I'm not using clockwise or anti-clockwise. Why? Right? Yeah, guys, don't worry. See, there is not one concept which I have not explained in English and explained in Hindi. There is not one concept, if it is difficult, which is something जो हिंदी में नहीं समझाया है और इंग्लिश में समझाया है, right? So I'm saying this is the balance I'm keeping for both the parties. Don't worry about this. Everyone gets everything, all right? So that's why. Focus. Yes, Saubhagya, definitely. Yes, correct. Right hand thumb rule. The reason I'm not saying clockwise or anti-clockwise is because whenever you want to use this word, clockwise or anti-clockwise, please make sure you give the perspective to the examiner. If I want to say clockwise, I would say I'm looking from here, right? So that's why I'm saying before using the word clockwise or anti-clockwise, don't just blankly say. If you are looking from here, it looks clockwise. But if you look from here, it looks anti-clockwise. So that's why, है ना? Okay? That's why. Fine. Actually, this question is coming. Don't worry, don't worry. Multiple coil solenoid hota hai, simple, है ना? Yes. Magnetic field strength at Q, it's more than P. Why? This is a straight current carrying conductor. The farther you go, the strength of magnetic field decreases. So it's better if you are closer, you will get more magnetic field strength. So that's why. At Q, it is greater than P, increases with current. If more current flows, you'll get stronger magnetic field lines. Simple, hai na? Don't worry. Meenakshi, I just answered this. Right? Come on. So, right hand thumb rule. The answer is something which you have already given. Malathi, this question will come in 11th, 12th. Don't worry. Quantifying magnetic field is not there right now. Alright? Yes, Fenil. हाँ उतना ठीक है. Yes. Shakti, depends on what factors. First, amount of current. More the current, more is the magnetic field lines. Second one, how close you are to the current carrying conductor. So two factors on which this depends. First, closeness from the wire. Second, how much strength of current is flowing, right? Yes. Yes, square law, Anoop. So this is the right hand thumb rule. Put your thumb in the direction of current like this and curl your fingers. If current is going up, you will mark it like this and you will show the magnetic field lines are going like this. Alright? Yes. Radius means how far you are from the wire, no? If you are far, means magnetic field is low. If you are close, magnetic field strength is more. Simple. Right? Yes. AB is a current carrying conductor in the plane of the paper. Now this is, guys, again an NCERT question. NCERT exemplar question, right? No, it's okay. Right hand thumb rule, you don't have to draw the hand as such. You can basically, you can draw? If this is I, you can say, this is what my magnetic field lines direction is. So this is something which you can do. And actually coming. So all these questions which you are asking, they are a part of this chapter. Don't worry, it's coming. Solenoid में clock face होता है दिशा. Yeah. So Fenil, a lot of these questions are repeated because they are NCERT questions. I don't want to change the question. In the starting itself, I'm telling you, there are few questions which I want you to focus. I mean, important questions, it's okay if you just look at them once more because these questions are NCERT and previous year questions. Whenever paper comes, it's a very high probability that many of these questions can just come a little bit distorted. That's why. Right? So, AB is a current carrying conductor in the plane of the paper as shown in figure. What are directions of magnetic field proposed or produced by it at points P and Q? R1 is more than R2, alright, R1 is more than R2. Where will the strength of magnetic field be larger? Right? Yeah, I'll have some water. Correct? Yes. Yes, cell count, okay. Q, alright. So one thing is pretty sure, na? Current is going like this. Means I can just put my thumb in the direction of the current and just curl my fingers. So at Q, what do I get? I get the magnetic field lines coming out of the paper or out of the screen, and this is the symbol for it. At P, it is going inside the screen, right? And that's why I have the symbol of cross. Going inside is cross, coming out is this. Fine. Then, strength is inversely proportional to the radius. How far you go, it becomes weaker. So that's why R2 is less than R1, means Q it is more. Fine. Yes. How will you write the answer? Applying the right hand thumb rule, direction of magnetic field produced by current carrying conductor at point P. So this is you are explaining at P which direction, and the direction is in which which direction the field is going, inside or out. Same with Q, out of the plane of paper. Magnetic field at Q will be stronger than at P because inversely proportional to distance, and that's why this is the answer. Simple. That is the notation for magnetic field, right? So, coil. I think this question we just saw, na? Coil, solenoid, we are moving towards that. Yes? Simple. So, Disha, when we say coil, na, single coil is what? It's a loop. When you add multiple loops, multiple coils, it becomes what is solenoid then. So that's why. Yeah, Maxwell screw rule is also fine. And actually, coming, your question is coming, don't worry. Come on, study the single thing first, right? And then you will go towards the coil. So this is the single coil, and then we'll learn towards the solenoid. Fine. So if the current is going like this, at each point, if you take this whole wire, small segments, if you take the magnetic field line because of each small segment, what do you get? Here, current is going like this, means magnetic field lines are like this. Fine. Naveen, yeah, kind of. In electromagnet, we just make sure we say there is a soft iron core in between. Simple. In this direction, it is coming inside magnetic field lines. So that's why you get this. And when you do this for each small segment, what do we get? We get in the middle, it becomes a straight line. So magnetic field strength increases with current and number of turns. So this is coming, right? How do you increase the strength? Every time it is same, current and number of turns. Fine, right? दिशा कुछ भी कर सकते हो. राइट हैंड थंब रूल ये क्लॉक फेस उसके लिए है, सोलनॉइड के लिए, राइट. कॉर्कस्क्रू इज फॉर straight current carrying wire and magnetic field around it. Clock face is for solenoid. Coil is what? Circular loop of current. Simple, that's a coil, no? Straight line in middle क्यों है? Just notice. Here and here. Both sides it is coming like this, no? When this thing happens from each side, in between it becomes a straight line, right? So this is why. And the easy way is from which side, so Disha, you are asking this question, hai na? From which side, which pole will it be? If this is a single thing, and that's why we are looking at it. If the loop is going anti-clockwise, we say it's a north pole. If it is going clockwise, we say it's a south pole. Simple, hai na? Don't worry, Meenakshi, it's coming. कौन सा कब होगा? We'll learn this. Don't worry, it's coming. क्लास होगी 8 बजे. Yes. All right. Come on, guys. Question. Srishti, yeah, don't worry. We'll discuss this in electromagnet. Yeah, it's a straight line. So this straight line will be more clear, Sunita, when you have solenoid. So every straight line will go like this. और आखिर में तो क्या होता है? It goes like this, no? Every north, when it starts from north, it has to go towards south. So that is why. Meenakshi, it's coming. This answer is also there in the end of this session. All right, come on. This is again an NCERT question, and I think some of you might have done this question before. Reflection of light? Not now. Explain with the help of label diagram the distribution of magnetic field due to a current through a circular loop. Why is it that if a current carrying coil has n turns, the field produced at any point is n times as large as that produced by a single turns? So you know what? This question is something which we just now discussed. Same. There is nothing special in this, right? Shorted means what? Sudden surge of current. Plus and minus. If you take a battery, there is no resistance in between, it just added. So it is what shorting, right? So how to give the answer for this? Now I'm not explaining this a lot because we have just discussed this. At every point of a current carrying circular loop, the concentric circles represent magnetic fields around it, which becomes larger as we move away from wire. And at center, these lines appear as straight lines. Now, when we are asking how to, the question is saying what? N turns the field produced at any point is N times as large as produced by a single turn. See, what did we discuss? How to increase the magnetic field lines? Number of turns. If you have N turns, every place the magnetic field becomes N times. No. So that's why. Magnetic field increases with increasing number of turns, and therefore direction of current in each turn of coil is the same. Every turn, right? Yes, nice. Yes, it adds up basically. Correct, you are right there. Yes, every place direction of current is same. No, 1 loop, 2 loop, 3 loop, and in each loop current direction is same. So that's why it's getting added. And that's why magnetic field due to each turn adds up. Therefore, if there is a circular coil having N turns, the field produces N times as large as that produced by a single turn. So this was a simple thing, right? Right? Yes. It's a simple thing. Fine. Now, the thing which was in demand a lot, na? The solenoid, current carrying solenoid. What do we have now? Multiple coils, no? Multiple loops next to each other. This is what a solenoid. Priyasha, you are 1.5 hours late. We are running a magnetic effect of electric current. So here, one side will become the north pole and another side will become the south pole. About solenoid, if you ask, magnetic field strength increases with amount of current, number of turns. So in whole magnetic field of electric current, what do you understand? Number of turns and amount of current. These two are very important factors, hai na? Nice. So Meenakshi, what I'm saying is, what is solenoid? When you have multiple loops in series, or you can say multiple loops next to each other, it's a wire which has been coiled multiple times. This is what? It's a solenoid. When current carrying wire is coiled multiple times, it becomes a solenoid. Okay? That's one thing. What the magnetic field strength depends on? Number of turns and amount of current. That is also fine. Okay? Now, how do you increase the strength? Inserting a soft iron rod in between. Why does it increase? See, this reasoning is not there in your syllabus, but I'm just telling you, it channels or focuses the magnetic field lines better. You can understand this in air. If the magnetic field lines had a choice to go through either the soft iron core rod or the air, they prefer soft iron core rod. It passes the lines better, basically. Okay? Diagram of solenoid, so this is good enough. Vishal. Copper wire ही तो है. Insulated copper wire, you have just done like this. Yes, Suryaka, correct. If you can, but you know what, Fenil? Lot of times, battery की बात शायद ना करे. They might just tell you current ऐसे जा रहा है. It's okay, you can reduce that, but I would say the clock face rule still helps. You know, it's convenient to you, whatever you want to choose. But still, I would say how to get the face anti-clockwise is what? North. And clockwise is what? South. The reason this mnemonic is very famous because it's very easy to understand. That's why. Right? So this thing. If you take a look at this side, you will see current is going clockwise. Oh, clockwise. Clockwise is south. If you take a look from this side of the coil, oh, current is coming towards me in anti-clockwise manner. Alright, anti-clockwise is north, so it is north pole. Okay? Fine. Normal copper wires, simple wires you have at your home, Paritosh. वो चढ़ा नहीं होता the plastic you have over the wire. वही insulation है. That is what. Okay? Alright. Chalo, 2019 5-mark question. Now You were asking me, na, what is a solenoid and everything. It's a 5-mark question which came in 2019. What is a solenoid? Draw the pattern of magnetic field lines of a current carrying solenoid, a bar magnet, and list 2 distinguishing features between the 2 fields. Now this is a good question. It is asking you first of all, what is solenoid? It is asking you draw the diagram of solenoid. So these are the questions you were asking, right? It's okay, Disha, yeah, works. Yes, Sanjana, you are right. Differentiating features is something which the question is asking, all right? Similarity is we know. Differentiating or distinguishing features of both. Thank you, flying bacha. All right. So, first of all, what is a solenoid? A coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. This is the definition, or it's a way of presenting your answer. It can depend, right? Yeah, black 999, it's fine. Similar kind of answer. So I'm saying you can frame this answer on yourself, right? Coil of many circular turns wrapped in the form of a cylinder. That's enough, है ना? Nice, Fennel. So Pradeep, what is a solenoid? बहुत सारे circular turns. There are many circular turns of insulated copper wire. What are you doing? Many turns of insulated copper wire to form a cylinder, a cylindrical kind of shape. That is what? It's a solenoid, right? Simple, right? So that is a solenoid. And both of the diagrams you can make. Just make sure when you are drawing the diagram, make sure this plus and minus, whatever direction you choose, you draw the north and south correctly. That is important. If you say plus is here and minus is here, so plus aise hai, right? If plus is like this, then, acha haan, Fennel, I got one thing with what you were saying. Currently, plus side, if you take a look, you will see there is a clockwise, right? Clockwise, and you will say clockwise means south. Fine. Here you will say north. If the diagram is drawn like this, so here, what do you see? Plus anti-clockwise. It became ulta, no? So that's why. So this thing is important. Yeah, nice. Yes, Anup, you're right. Case-based questions, Janil, it's not difficult. These questions are almost case-based only. है ना? Case-based questions में क्या होता है? The question gives you a lot of language. So just read the case-based questions slowly, properly. And there is a session I did specially on case-based questions. Have a watch. Yes? Okay. So that's why I'm saying clock face rule is important. Alright? Different from coil. Meenakshi, similar hai. Multiple coils are there. That's it. Selkoth plus clock and minus anti, it's not zaruri. It's not every time workable. So the reason I'm saying is, abhi to kya hai ki you are starting from plus and going in clockwise every time. In every book you will see this. But what if this diagram looks like this? That from plus you are not going like this, from plus you are going like this. Anti-clockwise ho gaya na? And that's why I'm saying, don't remember like plus is this and minus is this. Go with clock face rule. Okay? Positive terminal, yes. Positive terminal इसमें north pole है. That's true. ठीक है? समझ गए? So, thank God you told me this thing, this doubt. I might have not addressed this. So nice. This thing is clear, right? Clock face rule is important. Plus minus वाला मत याद करना. ठीक है? All right. ठीक है? A bar magnet, distinguishing features we have to say. A bar magnet always acts like a magnet, whereas a solenoid acts like a magnet. Only a current flows through it. We have to say difference, distinguishing features. A bar magnet is always a magnet, but a solenoid is only a magnet when current is running through it. You see, simple, right? ठीक है? अरे, my musings, don't worry. Don't worry. See, these baggage if you take on you before for exam, so it's always extra baggage, है ना? ये सब नहीं सोचना है, don't worry. अभी क्या है? What do you lag and how to work on it? Simple. Right? Very good, Paratush. Nice. Next. Magnetic field strength of a bar magnet is fixed but can be varied for a solenoid. Second difference could be, although it is almost same, भाई in solenoid what is working? Current is working. तो second point क्या बोल रहा है कि in magnet it is fixed, the magnetic field strength, but in solenoid you can vary. No, how? Current. You can increase the current, decrease the current. Number of turns you can increase, decrease. So that's why, है ना? Anitha, it's running 11-12 science channel. BYJU'S, JEE, BYJU'S NEET live happened there, right? So yes, okay. I promised you something that will have shorts and videos in between. Yes, it's very close. Force on a current carrying conductor. Now, what is the thing? If there is a current carrying conductor in a magnetic field, there is a force acting on this, right? Yes. For term 2, NCERT is enough. अब इतना time नहीं है, go for a lot of books. That's enough. How it behaves like a bar magnet, Meenakshi. You saw those magnetic field line patterns, no? That is similar to a bar magnet. If you bring a bar magnet close to a solenoid, it will show attraction and repulsion based on which pole it is facing. So that's why. Yes? So this is the force on a this is the force on a current carrying wire in a magnetic field. Which rule? When you want to find the force, you call whom? You call FBI. This is the force, right? This is the force, this is the magnetic field, and this is the current. And these two always remain same. If you go for motion and if you go for any other thing, this is magnetic field and current, this remains same. This is force, okay? Right? Fine, alright. So, I'll show you this. This is a nice shot. And watch carefully. So why are we using battery eliminator? It's a source, right? Current source. Right? So the reason I wanted to show this shot to you is, Anitha, don't worry. You got it. Practice and confidence. Two things I would say. Pushpendra, अभी तो time है, बहुत time है. Don't worry. Notification. Don't focus on what kind of exam you will get. Focus on what learnings you will take through. है ना? That is important. Yes. Force acting on a current carrying conductor. There is a force and you will use FBI. Right? FBI for this. Alright. Now, application for this rule. Yes? Yes, here comes the motor. I mean, I remember that scene. Okay, motor कैसे work करता है? It's okay. I think it's been a lot of time. All the best, Keithan. Yes? Yes, correct. So, motor. Everything is same. Right? There are two poles, north and south. In between there is a coil and there is carbon brush and a split ring commutator. Now these two are important. Application wise, I would say electromagnets, large number of turns in a coil, and armature. So, I mean, this is the way to increase the effectiveness of the motor. How? You can use electromagnets, large number of turns, and you can use an armature like this, right? Yes? Correct? So, that's why. Split rings, I think copper, no? Really? What happened? Are you saying the inner wire which is looking there? Strength of magnet. A permanent magnet, I would say no. Decreasing, I know. Right? Motor diagram, Surya? I don't think so. Is it? Can you tell me what's the problem over there? So, there are poles, and one thing is You have to find, first of all, current is going in which direction. And last, in my last class, I showed you this polarity can reverse. Examiner can reverse the polarity, right? And it can ask you a question that in which side, which direction of force will be there, right? Correct? AB arm has to go downwards, you're saying. Okay. North and south. Alright, let's see. This is positive, means current is going inside. Alright. It has to go up. No. Why down? You are saying this one is AB. No. This is A and this is B. Means this is plus. This is plus. Means current is going this side in and this side out. In and out. Right? Correct? So, current is inside, magnetic field lines are north to south, force will be up. No, that's why. Galat kahan hai? Why? Okay, see, focus. Dekho bhai, magnetic field line is going from north to south. Alright, current on the left side is going inside. Alright. This is in the plane. Magnetic field line is going like this. Current is going like this, right? So magnetic field is here. Current is inside. Force will be up. No, right? 3D, Silkut, 3D, right? So this should go up and this should go down. No, what happened? Why getting confused over there? Or see, I'm saying कि don't cram it from what you had already taken. किसी book में शायद polarity उल्टा होगा. What you are saying that will work if I reverse the battery. If I make the battery plus and minus, then it will work like that, है ना? So इसलिए ये ठीक है. Index finger तो magnetic field lines ही है ना? What happened? भाई north south, current inside, and this is the force. Why? What happened? Armature is the coil thing, है ना? The coil which is there inside, and with a soft iron core, we call it the armature. Index finger is magnetic field. This is current, and this is force. Simple, no? Proton, so it's okay. Magnetic field lines will go like this, guys. What happened? What's the problem? Put your hand towards from north to south, the index finger, right? North to south. Current going inside, this is the current, and then force is up. I think it's fine. Don't mistake, है ना? Right, left is fine. अपने हाथ से करो ना. Don't look at me right now. Alright, so this is about electric motor, and this is like an application. Charge the flow of electron, not proton, because proton, if you say proton, means the whole atom is shifting, and that's why. Anup and Selkot. So I'm saying do it on from your end. So this is what? This is simple, no? I mean, there are two pins on the two ends of battery, right? Means polarity you have given, magnetic field you have just stuck, and then there's a copper coil, it's rotating. Simple, है ना? That's why this is a very fun kind of thing. I mean, this is the reason I'm showing this to you is it's doable at home. That's why. No, today is not my birthday. दिशा, आर्मेचर का डेफिनेशन क्या होता है? जो बीच में कॉइल था ना, आर्मेचर इज नथिंग, इज द कॉइल इन बिटवीन द टू पोल्स ऑफ द मैग्नेट, है ना? दैट इज व्हाट आर्मेचर इज, व्हाट वी कॉल. नहीं, इंसुलेशन हटाना पड़ेगा ना. ये जो दो एंड है, सो दीज टू एंड्स you have removed the insulation, then only current is traveling. Alright? Why isn't it insulated? If it was insulated, then how would the current pass? Right? Okay? Yes. Alright, come on. Question number 9th. State Fleming's left hand rule. Come on guys, come on. Let's do it. पहले तो state Fleming's left hand rule, alright? And you know what, all these shorts, the reason I'm giving you names is all these shorts are there on the channel. I mean, tomorrow if you want to try something, you can just take reference from that. Write the principle of working of electric motor and explain the function of following parts of electric motor: armature, brushes and split ring. So, Diksha, your question will come over here. सूर्या, कुछ मिस्टेक हो रहा है. मैग्नेटाइट फ्लाइंग बच्चा, इट्स अ मटेरियल ना. Alright, yes, come on. CBSE 2018 5 marks. State Fleming's left hand rule. Now, whatever you learn, whatever you think, FBI, this is force, this is magnetic field, this is current. I'm thinking what you are taking is magnetic field as this and this is current you are taking. So don't do that. है ना? Magnetic field and this is current. This is force. Alright? हाँ, ये 5 marks का लग रहा है. So Fleming's left hand rule states that if we arrange our thumb, forefinger, Anita, I think this is a spamming going on, है ना? Focus. Thumb, forefinger and middle finger of the left hand perpendicular to each other. Thumb points towards the direction of force. Forefinger points toward direction of magnetic field and middle finger points toward direction of electric current, right? So I am thinking you are not able to give proper denotations for your fingers. This is magnetic field, this is current and this is force. Okay? Yes, Anurag, that's correct. Very good. Nice. Meenakshi, don't worry. Surya, लेकिन फिर Surya, still you can't get it down, है ना? North to south, magnetic field, current is going in, current, and it will go up. No, what is the problem we are facing? Right hand rule for motion. Which direction current will be induced if a conductor is moving in the magnetic field? Right? Okay. Yes. So this is left hand rule. What is the working principle of an electric motor? When you are thinking of working principle, it is what? There is a force acting on a current carrying wire in a magnetic field, right? Simple. Yes. Anisa, hold on. It's not the birthday. Right? It experiences a force whose direction can be determined by Fleming's left hand rule. Simple. That's the thing, right? Force experienced by a motor. Force experienced by conductors, by current carrying conductors in a magnetic field. Yes, right. Yes, Srishti, that also works. Alright, explain the function of following parts of electric motor: armature, brushes and split ring. Come on. Guys, hold on. It's about to finish. Just focus. Anita, I'm pretty sure you'll be blocked very soon. Focus here. What are you doing? Come on. I think people are not able to read the comments properly because of this. Yes, Kaushik. Hey. Armature. So, function of armature. What is the function of armature? Come on, tell me. So, Surya. Last time I am doing this. This is plus, means A to B current is going inside. North to south magnetic field is in direction. Sana, don't look at me. Do it yourself. North to south magnetic field lines. A to B current inside means force is upwards. Okay? Alright? Fine. So this is how at AB the force will be upwards and CD the force will be downwards. I'm thinking there should be no confusion now. Okay? Yes? Fine? Yes? Alright. So split ring commutator. So armature is what? This middle portion is armature. That's fine, right? Split ring commutator, it helps in reversing the direction of current at each half interval, at each half rotation. And carbon brush, what are the carbon brush doing? They are giving you contact, right? If this is the carbon brush and this is the commutator, it is rotating, but it is attached every time, right? That's why. Nice, very good, very good. Correct answers. And armature, coil wound on a soft iron core to increase power and rotates when a current is passed. This is the function. So armature, if you ask me the definition of armature, right? Kya hota hai? It's nothing, the coil in between. But what is its function? The function is increase power and rotates when a current is passed, right? So together, the coil along with the soft iron core, we call this thing as an armature. Okay? Yes, Meenakshi, correct. ठीक है सूर्या, या तुमने मेरे को परेशान कर दिया था? I got confused. Yes, nice, correct. Commutator क्या है? Those small rings, no? They are moving like this, right? So that is the commutator. What it is doing, reversing the current at each half cycle. Because if commutators are not there, twisting हो सकता है, and दूसरा, the coil will keep doing here and there. Yes? Rahi? Don't worry, we'll take it. Axle, अच्छा हाँ, axle, a lot of you guys asked in the previous questions. Axle क्या होता है? Motor is rotating, लेकिन there is a shaft connected with motor. अब यहाँ पर एक let's say fan लगा हुआ है, तो in your fan, that thing ना which rotates, नीचे पंखे लगे होते हैं, there is a fan. So this thing is axle, right? So armature is rotating, there is an axle attached with that, and then there is a fan or something, right? So that is axle. Split ring function for 3 marks, na? You can say if it is for 3 marks, you can also add what will happen if there is no split ring, right? You can mention those things and how split ring helps. You can first of all give this cycle where let's say A and B are here and C and D are here. Then once after one cycle, you can also show with diagram that now C and D are here and A and B are here. So after one cycle, what happens? After half cycle, what happens? Right? Make diagrams for a 3 mark question. Make these diagrams and give small explanation. That is enough. Okay? Right? Yes. Yeah, that's right. That's right, Pradeep. So split rings reverses direction of current. Armature, rectangular iron core wrapped by the copper coil through which electricity passes and due to magnetic field experiences a force and rotates. Simple. Okay? For 5 marks, though, it won't come for only 5 marks. It will add something more. Like this question, which we just did. Yes? Split rings are what we call as a commutator. Split ring commutator. See, commutator matlab kya hai? Which commutes, right? Which makes a link basically. Communication kind of thing. So that is why. They can ask self code actually. Yes. And in our previous session, we have done this question. In magnetic effect of electric current, any practice question session you would take, there is a one question of working. Don't worry. Yes, electromagnetic induction. So what is electromagnetic induction? There is a coil. There is a coil and there is a magnet moving near the coil. So this coil, to induce current, what does this need? It needs varying magnetic field near it. So if this is the coil and this is my magnet, if it is moving like this, no induction will be there. Why? Because relative position is still same. No, either you move the coil or either you move the magnet, there will be an induced current. But if there is no relative change in position, there is no current. And how fast the magnet moves, that will give you how much current will be induced. Okay? Fine. Alright. So electromagnetic induction, you can think conductor moved in magnetic field or conductor placed in changing magnetic field. So in first case, you will see there is a coil and there is a magnet moving. In second case, what do you see? This is still the same coil, but here there is no magnet which is moving. Here there is another coil, and we also know कि क्या होता है? क्या होता है? When you turn current in one coil, magnetic field emerges or arises. इस coil को क्या लगेगा? There is a sudden change in magnetic field. Oh, current induced. If you switch off, oh, magnetic field is gone. Again change. Current induced. Right? ठीक है? Getting it? Yes? So that's why I'm saying conductor placed in changing magnetic field. So always remember what happens. What does this coil need for an induction of current? It needs changing magnetic field, increasing magnetic field or decreasing magnetic field, but changing magnetic field. Fine, right? Thank you, Disha. Yes? This induces current. Fine. Alright. And deleted का अगर doubt है ना, I'm saying थोड़ा plus करने में नहीं जाता, because there is a history in exams. A little out of syllabus can still come, है ना? And at that time we are not in a position कि अरे तो delete हो गया था, so इसलिए focus, है ना? Induction is there वैसे. Fleming's right hand rule. This rule gives you that in which direction current will be induced if a conductor is moving in a magnetic field. Again, if you want to find the induction of current, you call MIB. M, I and B, right? This is the motion. This is magnetic field, this is current. So in any rule, the index finger is magnetic field and middle finger is current, right? So this is the induction of current, this is the motion, all right? Fleming's right hand rule. So this is what I'm telling you. Left hand rule and right hand rule. Right hand rule gives you induction of current when there is a conductor moving in a magnetic field. Left hand rule gives you what? Force on a current carrying conductor, it is moving in a magnetic field. Generator it won't come. Because it's a very huge topic. Yes. So when the magnetic field was increasing, let's say there was a deflection of current in one direction. When magnetic field is decreasing, the deflection of current will be in another direction. Simple, है ना? Split ring का क्या होता है मीनाक्षी? See. Okay, I'll tell you. Split ring का क्या होता है? कि if current is going in this direction, you want the coil to always go like this. No. If current, and every time on this side current should go inside. So a split ring will basically make sure that on this side current is always going inside and on this side always coming outside. Okay? Yeah. AC तो और बढ़िया है. It will keep changing. Yes. So electromagnetic induction. So this is a very nice and small demonstration you can do at your home, right? Magnetic flux, but syllabus में नहीं होता magnetic flux last time. That's why we don't use it. So in this, what you did? In a test tube, you just wound the copper wire. और नीचे you can use a battery also. And if you do this, watch, increasing and decreasing. Watch carefully. Do you see galvanometer goes like this, right? So galvanometer showed you direction of current, right? Increasing and decreasing. But LED does not know, no? LED को फर्क नहीं पड़ता है. Current is in which direction? In this direction, LED close. In this direction, LED close. And that's why, right? So that's why. This is electromagnetic induction. So alright, come on. Let's do this one question and then we'll finish the syllabus. Oh, Naman, ये हो सकता है. Oh, nice. No, Disha, it's not necessary. Alright, come on. Let's do this question. So this is one of the question which is like quite frequently asked throughout all these years. That's why I'm saying let's do this carefully and फिर खत्म करते हैं, ठीक है? Yes. अनूप, AC का क्या है? AC में you can assume current ऐसे होता है. That's why. Right? So that's why. And AC, I would say don't focus a lot right now. Two coils of insulated copper wires are wound over a non-conducting cylinder as shown. Coil 1 has comparatively large number of turns. Okay, coil 1 has large number of turns. Fine. State your observation when key K is closed. Acha, we have just studied this, no? This coil doesn't know which or why the magnetic field is changing. The moment you turn this key on, what happens? There is a sudden current which flows in this coil, which means there is a sudden appearance of magnetic field lines. For whom? For this coil. What does this coil see? A varying magnetic field. It says, okay, induced current. Fine. Alright. When key K is opened, then also it is fine. But tell me, if key K is closed and remain closed, there is a constant DC current flowing, right? There is a constant current flowing in the wire. For this coil, now there is a magnetic field around it, but it is not changing. This situation, when this key K is closed and it is remaining closed, the situation is, you know how? A coil magnet sitting next to it and just sitting there. There is no varying magnetic field, means no current. That's why. Nice, Disha. Yes, correct. So that's why it is. This animation will help you a lot. Current is flowing. Current turned off, there was a current. You turn it on, there is a current, but now there is no current. Watch. The moment you turn off, current in opposite direction. Okay? You can do this test. Yes? Understood? Nice. So, first, galvanometer needle shows deflection to one side, and second is galvanometer needle shows deflection to opposite side. Now, here, just last time, focus once. I want to tell you that a lot of you people, I have seen you struggle with writing answers in English, right? And for English speaking students, you might understand this easily, but the people who are more comfortable in Hindi, क्या होता है ना कि you are so habitual with Hindi that you get the answer, you know all the concepts in your head. मेरे दिमाग में सब होता है. I'm not able to put that down in English, है ना? So that's why. Watch and understand this very carefully, है ना? ये क्यों होता है? And how to overcome this. So English speaking students, just hold on for 2 minutes. I'm explaining something. I'm saying, दिमाग में सारे आइडियाज हैं, तो पहले क्या करो, रफ साइड में एक बार वो आइडियाज लिख लो. आइडिया क्या बोल रहा था? जब की के क्लोज हुआ, क्या हुआ? सीधे मैग्नेटिक फील्ड अराइज हुआ. फिर क्या हुआ? देयर इज अ चेंजिंग मैग्नेटिक फील्ड. ये मैं रफ में काम कर रहा हूं, ठीक है? चेंजिंग मैग्नेटिक फील्ड किसको मिला? कॉइल बी को. उसके बाद क्या हुआ? वहां पर करंट इंड्यूस हुआ. सिमिलरली नेक्स्ट का. सो हाउ विल यू राइट? इलेक्ट्रोमैग्नेटिक इंडक्शन. सो दिस तो आई न्यू, राइट? इलेक्ट्रोमैग्नेटिक इंडक्शन. So how will you explain? The current in coil 1 starts flowing when the switch is turned on. हमने यही बोला था, current on हो जाता है. Then this change in current causes a change in magnetic field, right? It is brought closer. It means till the moment you bring it close, it will change, है ना? Right? Monisha, just hold on. I might have missed your question, right? Changing magnetic field induces current in coil 2 due to which galvanometer shows deflection. So अपने आइडियाज को पहले रफ में लिखो और फिर उसको इंग्लिश में फेयर करके लिख दो, है ना? So this is something which you can do. Yeah, Disha, you are right. It does not mean it is stationary. Yeah, I'm exhausted, Sanjana. It's almost done. Don't worry. I'll go home, take a nice dinner. All right. Yes. Next, the current in coil 1 stops flowing when the switch is turned off. This causes change in magnetic field and induces current in the opposite direction. Hence, it shows deflection in opposite direction. And that's why, that's why I'm saying, organize your thoughts in rough and put down in English. If you have problem framing your sentences in English, that's why. This is my answer to you. And Monisha, I don't know what was your question. You can ask me again. Break nahi, we are just ending the class. Yeah. So, this is one small homework question. You can take a screenshot. Resistivity, Radhika, will not change. You can take a screenshot. है ना? This is the homework question. Continuous deflection के लिए, if you just turn the key on, there is a constant current. लेकिन magnetic field is not changing, no. So there is no current induction. That's why. All right. Yes. Time has come for home. Chitra, I might have missed your question, so that's why. ठीक है? Got this screenshot. अरे answer अभी नहीं देना है. It's a homework question. हाँ. Last में I would say for this thing, Azmi had asked one very important question कि बहुत frustration होने लगता है ना. You start getting frustrated. I'm studying, not getting anything. If you go for play, you feel guilty. So that's why I'm saying, don't do this, and it's okay. Get yourself reward. If you learn something, give yourself reward and come back to study again. है ना? So I'm saying don't worry a lot. है ना? Don't take too much pressure. I don't want my students to be too pressurized in your head. So don't worry. आज 2 घंटे का सेशन किया. I'm not fond of long sessions, but this was important. That's why I did it. All right. So take care and We have got you covered. I mean, you know that, right? Just learn it. Is to change in magnetic field because current. That's true. Yes. Which power formula to use? It will depend on the circuit. Which will give you a quicker thing. You can use all, but which will give you a quicker thing will come from practice. Normally parallel mein V square upon R hota hai. So that is one thing. Next class, all in one math term 2 marathon. Similar. So thoda, just eat healthy. 6 se 8 is booked now for this week, right? That's why, right? Power, Natasha, I would say go with Joule's law of heating, I square R directly. Thank you everyone, and yeah, like, share, subscribe if you feel it's good and it's beneficial. All right. So thank you all for joining, and take care. Don't take too much pressure. Again, I'm telling you, right? You got this. Don't worry. This was a revision thing. You got it. You understood it. Now practice. Practice. Fine. Thank you all. Love you. Bye bye.